Well, good afternoon, everybody, and welcome to the third and final webinar today from Smart Vision Europe. We're looking at DataRobot, and we're looking at building accurate predictive models with DataRobot. If you haven't seen DataRobot before, this is quite a very, very interesting platform. If you haven't joined in these sessions before, then you should bear in mind that we record them, so you'll be able to listen to them again afterwards. There's some slideware here, so we'll email out a link to the slides after the session's ended. And if you think it's particularly relevant for colleagues who are unable to join today, and you want a rerun, probably the best thing to do is just ask us, and we'll see if we can do it on a private basis, if you can get a few of them together. With regard to asking questions, I don't tend to check the chat panel as I'm going along. My colleague Rachel follows the chat panel. So she'll be monitoring that, and she's making sure everybody's logging in correctly. She's online with me. But I do follow up after the session's ended, so you can send the emails afterwards, or you can ask a question, and if you just bear with me, we'll answer questions once the session's ended via email, and give you a thorough answer. With that in mind, if you don't know who Smart Vision are, my name's Jarlath Quinn. I'm an analyst at Smart Vision, and I've been with the company for 10 years. Prior to that, I'd spent nearly 20 years working in the analytics software industry for SPSS and SAS and IBM. Smart Vision are a gold accredited partner to IBM to predictive solutions, and we're also a partner to DataRobot, which we're going to be talking about. We specialize in advanced analytics, AI, big data technologies, machine learning, statistics, all that kind of stuff. We don't just work with off-the-shelf or OEM software providers. We also work with open source technology such as R, Python, and Spark. We're a relatively small company, but we're made up of a team of specialists who have very deep working knowledge of statistics and AI type technologies across a range of different products. And in many different applications over the years, over the decades, in many, many different not-for-profit and for-profit organizations, including sectors like retail or manufacturing and government, central government, local government, housing, healthcare, telecommunications, manufacturing, utilities, etc. So today we're talking about DataRobot. If you don't know what DataRobot is, then it's described as a mature, enterprise-ready AI lifecycle platform. And that's the key bit here is AI lifecycle platform really is the key aspect of it. It's mature because it's been around for a while now. It's very rich in functionality. I'm bullet pointing a number of the aspects of the platform here because I simply can't demonstrate all of them in the limited time that's available to us. But an AI lifecycle platform is one that deals with things like modeling problems and supports the entire life cycle of the models, from model creation to evaluation, data, all things that happen to data before even the model's created, data preparation, ingestion, model creation, model selection, evaluation, interrogation, that type of stuff, monitoring, deployment out into the real world, and then monitoring again in terms of accuracy, in terms of fairness, in terms of availability, creation of apps for stakeholders to use to do what-if analysis. A number of different tools then that are built around this core capability. So it is also integrated with generative and predictive AI. We're going to be focusing on predictive AI, but suffice to say it works with large language models, of course, as every platform does these days. So LLMs is a core aspect of that offering. And it supports a very wide portfolio of data formats and data preparation capabilities, some of which are very intelligent and very, very smart. It supports automatic feature engineering, that's data preparation, selecting and creation of variables and fields or features that help with predicting an outcome. It will do that automatically. Automatic model building using multiple DataRobot native algorithms as well as third-party open source algorithms to support problems like classification, regression problems where you're trying to estimate a continuous value, and also anomaly detection, and things like time series. Quite a lot of capability in time series. It's got very deep model evaluation functionality. I'm quite impressed by the fact that you can really dig deep into how a predictive model is performing and interrogate it. It's got a strong emphasis on transparency of models, so being able to look inside the model and see how that particular model's been built via what it calls blueprints, and a lot of detailed documentation around the various settings of the model. If you want to know what ordinal encoding is, or what n-gram refers to, or what a gradient boosting model refers to, there's a lot of documentation around that. You just click on it and it opens it up. And it makes very good use of different types of data source. One of the more impressive aspects of it is it doesn't just work with numeric data. It does really intelligent things of text, image, and geospatial data, and will automatically incorporate that, with minimal effort from the user. So, for example, text data, as you'll see later on, it will associate terms with the outcome, where red is a higher risk and blue is a lower risk. You can see terms like that. So it's interrogating the text itself and saying what phrases, what words are associated with them. If an increase or decrease in the values or the levels of the target variable, the target thing, the thing you're trying to predict. Same with if you give it geographical data, it'll automatically map that and shade it according to a key outcome variable of some sort. And the same with video and image related data. It will automatically analyze images and that are associated with records that have been uploaded and find elements or aspects of those images which increase or decrease the likelihood of the outcome that you're trying to predict, whether that be a category or whether it be a continuous value. So pretty intelligent use of lots of different types of data. But also, it supports a code-first approach. A lot of these days, a lot of platforms have to have a code-first approach. So it's got good notebook capability. It's got DataRobot notebooks, which are fully Jupyter Notebook compatible. It's a single point for model deployment in multiple modes. So you don't, if you want to deploy a specific model, you do so from within this platform, and you can select the mode in which you want to do that, whether that be interactive batch, or whether it be timed or scheduled batch, or whether that be via an API to do real-time scoring. It supports things like champion challenger modeling and retraining policies. So if you've got live models running, it will support, for example, the ability to automatically train a model in the background to challenge that, or to support retraining based on a series of rules, a policy that you have. You want to keep your models relevant. Model governance options include things like monitoring the model performance, service help, so looking at whether the service availability, the accuracy, model drift, as well as governance issues such as fairness or bias within the models. And generally a workbench interface where different personas, whether they be coders, or whether they be business analysts or data scientists using the interactive capabilities of DataRobot, or whether they be stakeholders, can collaborate with one another, all within one browser-based interface. Okay, so it turns out there actually are two modes to get started. I'm going to show this to you in a moment, but suffice to say that because it's being updated, when I first started working with DataRobot, we used the classic approach. That's the one I'm going to approach. But if you yourself want to have a go at this, you can absolutely register with DataRobot, and it lets you have obviously a free account to play around with it and try it out yourself. You'll notice that there are two different ways to get started. One is Workbench, where it will take you through step by step to create your own use case, and it'll just manually walk you through selecting the data, selecting the target, setting up how you want to predict the outcomes, etc. Or this kind of classic approach where you can simply begin a project by dragging a data set here. If I double click and come out, I just right click and come out into my Chrome based browser here, you can see it, begin a project by dragging a data set here. Well, I've got a data set I want to work with. The data set I'm working with is this data set. Just to introduce it, it's it's an issue around predicting loan default. It's one that DataRobot use in DataRobot University, which I've attended some of the training sessions there on. And it's a data set called Lending Club. And this is a data set where, obviously, where people are being lent money. They're usually non-standard customers who can't or people who can't normally get a loan under other circumstances. So they're kind of high risk. And therefore, it's really incumbent upon Lending Club, the organization, to make sure that it assesses their risk before deciding to obviously lend them money. So if I wanted to add my data set for this, you can see I've got a bunch of different data sets here. If I didn't have flat files as I'm working with, if I click on data source here, you can see that, if I could add a data connection, it supports a very wide range of different data sources. We're working within, obviously, a cloud environment here, browser-based environment. And it's important to bear in mind that the instance itself, DataRobot cloud environment itself, can be installed and configured in a variety of different ways. It could be a virtual private cloud that supports your instance of Azure or AWS. It could be other cloud-based infrastructure, as well as virtual machines. It could be Hadoop clusters, or it could be on-prem. In which case, you may be connecting to existing online databases or existing relational databases. So these could be flat files, data lakes, cloud-based warehouses, Hadoop standards. But it can also upload, of course, flat data, and it supports, suffice to say, a very wide range of different ways in which you can get your data on there via URL or local file. I could click local file here, or I could just click to my Explorer here and say, okay, well, let's just pick Lending Club here, DataRobot demo Lending Club, and I'll just come down here and just drop that on. This is, I think it's a CSV file. One of the things I was quite impressed by was when I first tried it out was I experimented with changing that file so it wasn't comma separated, but was tab separated, and then pipe separated, and even, I think, semicolon separated. It didn't care. It didn't matter. It says it accepts CSV data, but in reality, it gets on with whatever separator I could come up with. It was quite happy to start uploading that data and interpret it correctly. So at the moment, you can see there, I've literally just dragged the file onto it. I'm not connecting to an online resource or a data lake or data warehouse or anything like that. At this moment, it's just reading the raw data, having uploaded this data set, which has about, I think, 10,000 rows of data in it. And it's making sense of it. At the moment, it's reading the raw data. In the moment, it's going to get to stage 3 and do some sort of exploratory analysis. At this point, it's saying, what would you like to predict? It isn't quite finished yet doing its exploratory analysis, 6%, 7%. But if we look down the bottom here, we can see, if we scroll down, we can see the fields that are coming up. We've got a field here, which is 2 unique values. It's a categorical field. We have a field here, which it decides there's too many levels to work with. It's guessing that it's probably an ID field. It is, in fact, grayed out. It's member ID. We're not going to be using that for modeling purposes. We've got another categorical field here, which is called loan status. We've got text file here, which is employer title, employer. Length of time as an employer, it's categorical, whether or not you're a homeowner. Annual income, and then you've got something which is very few values, payment plan. So you can see immediately it's starting to do its description, which I think is the reason for getting your loan, your description, the little box you type in, your zip code, and your address state, and then other things like whether or not you've had any loan delinquency in the past 2 years, the earliest point at which you ask for a line of credit, in months and in days. This is actually a date, and it's automatically pulled out the month, the day of the week, and the year that's happened. So the first point at which you try to ask for a line of credit. So there's a lot of information here with regarding to inquiries in the last 6 months, months since last delinquency. We've got stuff here around this one. Is quite important. Revol util percent. That is what percentage of the available credit line to you the person has used. So if you've got a credit line of $10,000 and you've only used up $2,000, that credit line, it's a 20%. Whereas if you've got a credit line of $10,000, you've used up $9,000, it's obviously 90%. It's quite important. and a bunch of other fields there. So we've got 30 different features or 30 different fields here. So you can see it's reading it at this point. So I can actually click on these fields here. Let's look at something like annual income here and just click on that. And you can see right away, it just shows me that as a histogram. So that's quite nice. I can interact with it. I can see it as a table if I wanted to. I can actually ask it to change the number of bins it's showing. I can show if there's any outliers there. I can click on it and say, show me, calculate if there's any outliers and show that. So it automatically masks them in case you've got any issues with it. It's asking me at this moment now for the next thing to select the target and indicate what the target is. The target's actually right at the top here, which is bad. Is this loan bad? Basically, yes or no. You can see we have some outliers here. It's actually showing you some people's income is much higher than standard. It's way beyond the what we call Tukey's limits here on the box plot. So that's the upper 25% of the box plot, the middle 50% here, bottom 25% here. And here's our target category here is bad. You can see that the majority of people loans aren't bad. There's a minority which have been proven to be bad. Our job is, of course, to indicate to build predictive models which are going to tell us whether or not that's a bad loan or not. So we're doing that. So let's go to the top here and say, look, yeah, what's my target? So I just need to remember roughly how it is. If I type in I, you can see it just search everything I. There's is bad. And you can see here that it says, well, that's a classification variable, so it's a classification problem. If it was a continuous variable, we're looking at how much money was paid back, then it would be a regression problem. And if it was time-aware modeling, if we're doing time series, we could set up for time series analysis at that point. At this point, I can start to building models just automatically using these prepared variables, this prepared data that it's got. It's got some information here on quality assessment. So it's giving information on whether or not the data's got any issues of it, whether or not it's got outliers or disguised missing values or excess values, excess zeros, etc. That really starts to come into its own once I start the modeling process, which you can see here, there are different hierarchies of it. Autopilot's kind of like the medium tier where it's going to build a bunch of models. Manual is where I can override it and tell it exactly how I want it to build models. And comprehensive is kind of the nuclear option where it builds every model it can. The difference, of course, is the level of intensity and level of time. So if I just click quick here to get started, to illustrate it to you, you'll see that the modeling process begins. Now it's saying setting the target feature, and it says, okay, I'm using 0 out of 10 workers at this point. I can actually increase the worker count so it can use more threads. I'll turn that up to 10. And it says I'm setting the target feature here. I'm creating CV and holdout partitions. So this is very important. CV stands for cross-validation and holdout partitions. Basically, it divides the data into units here. So we've basically got it creates 5 cross-validation partitions. That's 5 partitions randomly in the data of about 16% each, and it leaves the last 20%, which is called the holdout sample. And what it's doing is it's basically having a competition here. It's building models, trying out many different algorithms. It builds them, let's say, on the first 16% of the data, which in this case would be about 1,600 records, and then selects the best, the best models as it's doing that. And it top slices the best of those and says, okay, now you get exposed to the next 16%. So you go through to the next round. And it keeps doing that until it gets to about 64%. And it picks a champion model, if you like, which then gets applied to the holdout sample, which is the last sample is held back. So it basically works its way through the data set in partitions, picking which algorithms work best. And as each round passes, as each heat, if you like, it's like a track and field competition. As each heat passes, it's picking the top X number of models, depending on the mode that you're working. You're working smart, working in the quite quick mode here, as opposed to the more comprehensive modes that we have. It's top slicing them and saying, okay, you go through the next round until eventually we get to, the final number of models, which get onto the leaderboard. At the moment, it's found 9 models. That's how far it's got. But while it's building these models, we can see that it's actually giving us a little bit of information on what it's found in the data. So it's found something here called, it says loan status here. Has a problem with it, and it's not going to use it. It's called target leakage. So target leakage is an issue that happens a lot in data where a variable contains information that you would not know unless the outcome was known. In other words, it's a self-fulfilling prophecy. So we have, is the loan good or bad at the moment? And we look at loan status, that's just showing us the details of the loan outcome, whether it was fully paid or whether it was charged off. If it was charged off, it meant it was bad. It's a bad loan. If it's current, that means it's still current. If it's a grace period, then if it's late, then it's bad. And if it's late 16 to 30 days, then it's bad. So basically, you can't use that to predict the outcome. It's unfair. And as a result of that, it won't go into the model itself. We've got other problems here. We've got, well, not issues, but it's just things we need to be aware of, that we've got issues around extreme values that we saw regarding inquiries in the last 6 months. What I really like about it is if I pick one of these fields here, like annual income, it creates this extra kind of line over the top on this extra scale, which is showing what percentage of people were in the bad group. So what we can see is that, you know, low income people low income, they've got a higher rate of percentage. It starts to drop as the income goes up, as the income, increases. It starts to drop. And then as the income gets higher again, it actually starts to go up a bit. And apparently this is quite common in a lot of loan situations where people on higher incomes actually kind of living beyond their means and credit cards, etc. So up until this point, it's dropping. And probably the people with the lowest risk likelihood are people in this decile here. I could change the number of bins and say, okay, let's increase that to 30 bins. You can see it's starting to get a little bit chaotic as we get into the extremes here. But it's fascinating because it means we can overlay the target field and see the effect of that on the category field. So for example, here we've got some text data here. So we've got text data here. Let's go down to a field like description, which we got down here, which is the reason for actually having the loan, what they want to do. We've got their employer title. Let's go variable, sort by variable type here. Here's description. Look at that. If we click on that, it's really intelligent. It's actually, if I just zoom out a wee bit, it's actually picking out the key words in the description and why somebody needs it, and which words are mostly associated with high risk. So bills, people saying I need to pay my bills. That's you know, high risk. It's a high risk situation. People talking about company, it's lower risk. It's blue. People talking about stable job, lower risk. People using the word need, I need, is actually high risk. We see that. We actually see that happening at that point. Later on, we'll see a little example of that. People talking about school or home, low risk. And the same thing you get with job title. You see similar sorts of things. So really, really interesting way, even before we get to looking at the resultant models, it's showing us, you know, some really powerful insight here, just playing around with this data here. It also, we can sort them in order of importance and show us which features are the most important for predicting the outcome at that point in time. You'll notice that it's creating this feature list. Feature list is all features. I could say DataRobot reduced features from model 12. That's one of the models. Informative features, that means dropping any features or variables where they're just not informative, they just don't predict. And informative with the leakage removed is probably what we're going to end up with. That's when we remove that variable that had the target leakage in it. We can see here, here's the revol util percent. That's your available percentage. You can see that increasing as you use up your credit line. In percentage terms, the risk increases over time, as we'd expect. Okay, so it's still building models. We can see the models here in the background. This is the models it's building. If I click and run that, and it takes a while for it to do that. Even in quick mode, this is called the leaderboard. So in true kind of Blue Peter style, I've got one here that I've completed earlier. So I've got lending called complete. And in this case, I didn't go for the quick method. I actually went for the comprehensive method and said, just build as many models, you know, as you possibly can. Took a while for it to do, but it actually built a leaderboard of 142 different models. That's how many models, algorithms actually made it onto the leaderboard when I said, just go for completely comprehensive. And if I click on that, it takes me to that leaderboard, and we can see them here, and we can see that the one that it's chosen, it's made it all the way through, and it's got exposed to 100% of the data. and with the based on informative features, informative variables with the leakage removed. So we've got rid of junk variables and got rid of the leakage removed, and has been exposed to the holdout sample. Is this one here called the rule fit classifier? We'll take a look at that in a bit more detail. The first thing it does is it's looking at validation. The validation is just the partition, the sort of initial partition that it was exposed to that helped it select the best sample. And then the cross validation is how well it's performed on average across all of the different partitions, because of course it's got to get exposed to the first 16%, then the 32%, and then up to the 64%, and eventually to the 100% of the data when we include the holdout sample here. And it's using a method called log loss. When we went to build the model originally, we actually tried to build a model, it automatically picks a metric that it wants to use. We could have overwritten it and said, no, we don't want to use log loss. Log loss is a pretty good one. Smaller numbers means less error. But we could have chosen something like area under the curve or Gini norm or any other type of criteria or criterion that one would use to measure the overall accuracy of a model. And we could have done that right at the start when we click the start button. So it does give you freedom as to how the models are selected and what criteria you're using to look at it. So this one here is the one that's chosen as champion. You can see it says recommended for deployment. It's got a little cup next to it, prepared for deployment. It's called model 264, based on blueprint 67. And it was selected against 80 frozen parameter settings were applied to 80% of the data. It got to 80% of the data. It said, right, it's good enough for me. I'm going to freeze the parameters at that point and then apply it to the rest of the data. And if I click on it, I can actually see the blueprint itself and how this model has been built. This is some sort of rule fit classifier. So think like a decision tree or something like that. You can see it takes the data, it's split the categorical variables off, and it's done one hot encoding. So it's turned them into ones and zeros. If you don't know what that means, you can click on it. You can see what the parameter values are, how it did that. And you can also look at the DataRobot documentation around that. Really powerful, where we can look at one hot encoding documentation with references. Similar sort of thing here. We can say, well, let's look at how is it dealt with the text variables. It's used a matrix of word grams, co-occurrences, as opposed to n-gram, which another method uses. We click on that. And again, we can see the parameters there, and we can see documentation about that and how that's been set, and references associated with what the reference are to underpin that. Really quite transparent at this stage. We've got a lot of information here in the background about this model. Obviously what the accuracy is, why it's been selected. We can see why it's been selected, because if we look at the cross validation here, we can see that the next ones down are just marginally. This is the rule fit classifier. This was the original one. This is model blueprint 67. It's just marginally better than these other ones down here. As we're looking down, these numbers getting slightly larger. We can see that a very close runner-up was the light gradient boosted trees classifier for early stopping, which get very similar sorts of values here in the validation and cross validation. We're down to a few decimal places, the differences between one and the other. So again, you could choose that. You could actually click on one and say, no, I want to promote that to be the champion instead, because I prefer that algorithm or I trust it more. Again, returning to rule fit classifier here, we can start to evaluate this and have a little look at that. Before we do so, you can see at the top here, leaderboard, we've got a few other things here. We've got insights and learning curves of speed versus accuracy. This is really the global stuff that's happening in the background. So, overall, irrespective of the models, if we look at insights here, we can actually see, for example, just independently of the model building, we've done our own tree-based variable importance, and we can see which variables or which features are most important. It's actually the description, the reason why they're choosing it is one of the best predictors. That's one of the best predictors has got score 100%. Second best predictor is annual income, and then revol util and revol util percent. Remember that these are kind of one's a function of the other. This is the actual raw amount of credit line that they've used, and this is the percentage use of credit line. And then inquiries in the last 6 months and DTI, that's using a random forest model to assess that. You could switch and say, okay, I want to use a different model and show me the variable importance based on that. But really important, really interesting to look at even before you get to the the model itself. Then you got things like variable effects, which ones have a negative or positive effect upon the outcome. So you can see this is a regularized logistic regression here. It's actually using with L2 regularization. And you can see the variable effects on that. And you can say, okay, well, I can look at something else. Let's look at the word cloud. We can go to word cloud here and we can choose a particular feature. We can look at, for example, employee title. And see this employee title. When employee title is school, if it's school or corporation or insurance or technology, these are kind of low risk employers and that they have, as opposed to terms like mortgage or club or national or board. These are kind of higher risk, if you like. So and we can look at description, loan description again. You can see that years is very, is kind of a high risk term to use. Card is a lower risk term, interesting enough. This is overall irrespective of that particular model. You got stuff about learning curves, but which models learned fast? As you can see here, as it's increasing the sample size, as they're getting exposed to it, you can see the error starting to get smaller, and which models end up in being chosen here. You can see this yellow model here. This is extreme gradient boosting classifier. This is one of the best models that we got here. There's a rule fit classifier, just slightly higher in the validation data. And which ones make it through to the holdout data? Well, that's the final list. Then we've got speed versus accuracy, if that's really important. We've got a measure of accuracy here. Log loss, the larger the value, the less accurate it is. So you can see that this one here, this is an extreme gradient boosting. It's pretty accurate and it's got it's pretty fast as well as a comparison against our champion model, which is the rule fit classifier. Okay, let's look at this rule fit classifier and we'll look at it in a bit more detail here. There's various things we can do. We can click on understand to interrogate it. I'm clicking on understand to interrogate. It's initializing the data at this point. It's saying, okay, look, these are the most important for this particular model here. These are the most important features I use. Description again, we saw that earlier. Inquiries in the last 6 months and annual income. Revolution utilization or your credit line utilization, and then how long the account's been open for. That's in the cross validation. If we look at the validation, it could be potentially slightly different each time as we go through this. And we can look at feature effects. If I look at feature effects here, this is the effect that they have and their relationship to the accuracy. This one's a bit inquiries in the last 6 months. Most people are kind of 1, 2, 3 inquiries, and there's some sort of extreme values down here of 26 inquiries. Probably not the most easy one to make sense of. If I look at annual income here, you can see that this is a rule-based algorithm. So rule-based algorithms tend to be people falling into buckets. So as a result of that, the proportion of people who are high risk versus low risk, you can see falling into buckets here as the annual income increases. It's kind of bucketed there. And we can see that this is actually a measure here, which is a partial dependence. Partial meaning it's taking into consideration like a partial correlation, the presence of the other variables. So it's controlling for the presence of the other features in there. But I can overlay on top of that the predicted, and I can overlay on top of that the actual. You can see that as we get to the higher incomes here, we saw that some people were quite high risk. It's starting to get quite chaotic there. So it's not so good at fitting on the higher incomes, but it's pretty good close fit here on the lower incomes. The relationship between the predicted and the actual we can see here, and we can switch one on, one off at that point. Really useful prediction explanations here. If we click on prediction explanations here, this shows you individual cases and shows you like the top 3 and the bottom 3 cases by default. You can ask for more of them. By default, it shows you the top 3. And it also shows you which variables are really describing, which variables are really driving an increase in the score, the likelihood score, or a decrease. So plus signs mean an increase in the score, and an increase in score here is related to higher risk. So this person here is case number 6,492. Okay, so and their prediction is quite high. They're quite high risk here for a 38% chance of being a bad loan. And the 3 biggest variables that had an impact on that were things like their description, their annual income too low, and they're utilizing 75% of their credit line. What's the description of the reason why they wanted it? Well, they said need a larger truck. So remember, need was associated with negative scores. Need a larger truck for growing business. Always make payments on time, they say. But that, unfortunately, no dice. That's actually downgraded their likelihood to get the loan. The next one down here is row number 646. Let's see what their description is. You can see quite a big impact there as well. A bit of an essay here on stay-at-home mom for almost 2 years and began chasing my dream, blah, blah, blah. So it's picking out those words, and it's saying that, they're quite powerful with regard to assessing this person's likelihood to repay the loan. It's actually made them quite high risk. If we look at the lowest predictions, these are the people down here in this one, so the very low risk ones. You can see that inquiries in the last 6 months is a value of 4. And their annual income is much higher at 125,000. And description, just kind of had a moderate impact on it, is it says the loan will be used to pay down a credit card debt. It turns out the credit card debts here are associated with relatively low risk here to maybe a consolidation of debt. So we can move these values along. Say, no, I want to see the people in this zone. I want to see the people in that zone. The prediction distribution, who's high risk, who's low risk, and then update it at that point. So really good way to interrogate the data. What about the model itself and how accurate the model is? If we click on evaluate here, we can go to evaluate. It'll show us what's called a lift chart. Again, this is a very common chart type that one gets when trying to evaluate how well a model works. The blue line here represents the I think it represents the prediction. You can see predict here. And the orange line represents the actual. And basically, it's saying, if I look at the predicted value here, the bottom 10%, that's the bin, 10 to 20%, 20%, 30%, 30%, 40%. These split it into tenths at this point. What is the risk? What is the actual risk, and what is the predicted risk, and how closely do they match one another? Well, they actually match each other pretty close in terms of the validation. And we can search on and compare one against the other. So that's pretty good. That's based on the holdout sample here. If I look at the cross validation, it's even closer. So you can see why it got through. Holdout sample, it hasn't been trained against. That's the last 20% of the data. So given that this is 1,600 cases, and each 10%, that's 3,200 cases it's been applied to, and the validation here as well, quite close fit. What about standard ways in which we might assess the model accuracy using things like ROC curves, ROC curves, receiver operator curves, gains curves, if you're familiar with that? Here it's showing me that the probability of the event for the group that's made it through, the group that's a good loan and the group that's the bad loan, they're actually overlapping quite a lot here. It's quite hard to discriminate between them. One way in which one might do that is one might say, well, okay, look, find me the cutoff point. The display threshold here, the cutoff point seems to be about 12%. That's based on the holdout data. I could say, well, let's look at the cross-validation, which is what you're trained at. Now the discrimination is a bit more. It's actually 13%. And you could ask it to maximize the value. You could say, okay, I want you to, the data slice here is all data, or you could say create a certain slice of the data, saying the bottom 10%, something like that. The display threshold here is 13%. I could say, I want you to maximize a statistic like F1, in which case, where would you cut it? It's at 13, 18.13, 18, or MCC. What are F1 and MCC? Well, there are statistical attempts to come up with a number which separates as best as possible the false positives and the true positives and the false negatives, and the true negatives from one another. In other words, you can't just use overall accuracy, because it could just predict everybody to repay their loans, and it would still be 80% accurate if only 20% don't repay the loan. So these statistics here, like F1 and MCC and Gini and things like that, there are attempts to try to find the best discrimination between one group and another. One of the best things about this, though, is these charts are interactive. So as I move this ROC chart down here, this is really just the false positive, true positive rate against the false positive rate. I can move this around here. You can see over here how many true positives, how many of the 1,000 people who didn't pay their loan back does this model detect. If I move this up, you can see I can say, well, if I cut it there, look, and get more of them. But what's happening is I'm also getting more false positives. And this is really at the heart of it. So it's really powerful at that way of trying to find, where the best cutoff point is. It's giving me these extra F1 scores, these ways in which we can evaluate the model. There's tons of them. We've got area under the curve we could ask for there. We could ask for the false. Maybe the false positive rate is more important for that situation. We're trying to minimize that rather than the true positive rate, that type of thing. So you can choose whatever cutoff point is best at that point, and then deploy your model based on that. Based on that cutoff point, having interrogated. What else have we got? Well, we've got tons of other things here. We can do advanced tuning where we can say, actually, I want you to go in and just search within this model itself. I want you to search the parameters to kind of, try and find the absolute optimum settings within that. We have a lot of other stuff here with regard to understanding, describing the model and blueprint, predicting the output. If I go here to predict, I could say, well, I want to make predictions at this stage. And I can say, okay, well, I'm happy with this model at this stage. I want to make predictions. I want to choose a file. I'm going to choose a file. I'm going to choose a local file at this point, and I want you to predict from that. And I want you to use this local file here, which is scoring, which is just the same cut down of the subsample, the same data set. And you can see here it immediately starts scoring it. So this is why I can just test it and say, well, look, I've got some testing data here in a CSV file format. I'm just going to want you to test it. The prediction threshold here is 0.5. I could say, actually, I want you to maximize F1. 0.5 is a bit strong, so take it down to 1.2. Optional features, you can add in optional features that you want to add at this point. And once it's computed that and uploaded, saving it currently, you'll be able to compute the predictions. You'll be able to actually see the predictions. So this is one of the simplest ways in which we can deploy the model itself, just by looking at the results and say, okay, let's compute the predictions on that. There's 500 rows of data. It goes off and starts doing that process. You can see it here running in the background. Will fit classifier. It's applying it to it. And eventually it just pops up and says, okay, here's what the results of that look like after I've applied this model to those 500 records. As I say, this is one way in which that can be done. It's one way in which we can actually test the data and see how well it's performing. But it's not the only way. So we could actually say, download the prediction to this point. Let's have a look, see what you got. Let's give it a second, see if it's going to download it. It should do it eventually. It says downloading predictions. Okay, just give it a moment. Here we go. Okay, there we go. Open it up. See if we can see it. Open it up in Excel. And it's just basic saying, okay, here's your row IDs. If you want to test this, here's your row IDs. You got row 500 of them. Here's your prediction. I predict these first two cases here to be bad loan. I predict this one here to be a bad loan, this one to be a bad loan, based upon these values that you're given, these risk scores, 10%, 13%. So it's just one easy way in which we can deploy that. There are a bunch of other things we can do at this stage. We could say, okay, well, do you know what? I'm not really sure about this. I might want to compare that model against the next closest one, which was the extreme gradient boosted model. I could say choose that from one of the model listings. Again, very useful because here we have one lift chart overlaid over the other with based on validation. Let's change the bins to 10 bins, something like that. See how well that works. And basically what's telling me is that one of these models here, which is the rule fit classifier or champion model, it does better on the assessing the risk score. It's more likely to assess higher risk on the top 50% than it does on the bottom 50%. This other model here, which is showing you extreme gradient boosting, it's more likely to assess higher risk on the bottom 50%. So that they tend to disagree here with regard to where they're applying across the data. That's dual lift. If I look at the ROC curve here, you can see there's really not a lot of daylight between them here. It's just it's a little bit higher up on the rule fit classifier. It's just doing a slightly better job. And you get on in profit curves at this point. So there's a ton of other things we could do here. We could go to deployments if we wanted to at this stage. And we could see what has been deployed at that stage. Coming back to the model itself, if we want to click on this and say, okay, there's all these different measures. We can look at bias, etc. We could click on that model. We could deploy it from here. We could right click here and say, okay, I want to deploy this model out to, well, what do we want to do? We could deploy it out to a API so that it could be scored in real time. We could deploy it out to a component where we can create our own timed or calendar-based scheduled scoring, or we can do interactive scoring. We can actually just do a batch score as we did earlier on where we tested out the model. So a lot of different ways in which you can do that. When we get to deployments, models that are deployed here, you can see that I've had one from 2 years ago, and I've done this again more recently. Although these aren't live because I'm just running them on my laptop, you can see that in the deployments here, you got stuff like batch jobs you can run. I haven't got batch jobs. You've got prediction environments where you can add a prediction environment and API to that if you like. And the deployments itself, you can look on things like the health, the service health at that point, the data drift, which will give you information about that. If I just click on this one here, look at all these different measures I can have: accuracy over time, data drift, fairness, humility, usage of the model, predictions themselves, adding and challengers, adding in my custom metrics if I want at that point. So there is a ton of capability that gets unlocked once you've decided to deploy a model, put it out into the real world, have it working in an operational environment, and where you need to evaluate it. So some screenshots of that just to finish up. Here, let's have a look. So there's some deployed models. So you can see, for example, a screenshot here where we can see activity over time and whether or not there's drift. Drift refers to where the data drift is when the data itself no longer correlates, if you like, in the same way with the target field. So, for example, let's say the interest rate wasn't a really important predictor of whether or not people were likely to pay back a loan, because for many years, as you've had quite low interest rates. But suddenly, a change in inflation means that variable becomes much more significant. So it starts to drift at that point, or it becomes less significant as inflation starts to fall. Whether or not accuracy is changing over time. So we're looking at different models here, and it's giving us how many are passing, how many at risk, how many are failing at that point in time. Another example of that, let's see what else we got. We've got service health, service availability, if it's a live system at that point, whether or not we've got, how many calls we've got, how many errors, how many consumers are consuming at that point in time. And we've got accuracy, model accuracy, and then we've got different measures. We've got log loss, whether or not that's the log loss, the error is increasing, or whether or not the area under the curve is falling, or any of these other measures that we're using over time. And we've got data drift here. Again, this is an example of data drift where there is a field here which is failing. It might be the home ownership field. Yeah, the home ownership field is failing where there's a difference in ownership. People are actually owning based on training and scoring. We're seeing some differences there between the scoring data and the training data, and that indicates that the model itself should be updated and perhaps refreshed or rescored or rebuilt. Okay, taking this up to the R there, just so you bear in mind that we do support DataRobot, and we provide consultancy implementation around that, analytics advice. So our consultancy services include things like project support, whether it be 1 or 2 days of consultancy time, or more deeper analytics advice, 3 to 5 days, or an analytical deep dive where we explore your data. your data landscape to test out hypotheses or develop an application, such as a working model that you might want to test in platforms like DataRobot. With regard to sourcing software such as DataRobot or IBM, you can source your analytical software directly from us. As I say, we provide training consultancy services around that, including identification of recruitment of analytical skills in the organization if necessary, virtual training, side-by-side support, a blend of training and consultancy. And we generally offer advice on no strings attached support to customers of Smart Vision as well as non-customers. The best thing to do is just reach out to us. We have formal technical support services around the IBM SPSS product line. In the meantime, I hope you found that useful, and we look forward to you logging again. We will be having a regular webinars throughout the end of 2023 and into 2024. So if you look at our ongoing webinar schedule, you'll see other topics that we're covering in the future 12 months. In the meantime, thanks very much for logging in. Look forward to seeing you again. Thank you.